And so the last speaker of this session is Jochem Braakhekke, and who is a research associate at the remote sensing laboratories at the University of Zurich, and also scientific consultant for remote sensing data national point of contact. Maybe it was not exactly the right word out there, but like when we discussed and prepared the session with Jochem, he made a very interesting point that I could completely relate to, saying that many of us would like to use satellite data, but we don't know like how to pre-process them, where to get access to the data. And I think he will give us a lot of clues on how actually do that. So really looking forward to this call, and the stage is yours.
Sweet. Thank you very much. Thank you all. Well, that's quite a humbling experience to be surrounded by professors and assistant professors and people that are a little bit more on the application part than I am. Because as introduced, I'm a researcher in the Earth Observation Application and Service Group at the RSL at University of Zurich. But mainly, I'm a consultant for the National Point of Contact for Satellite Data. And what we do is promote, foster the use of satellite data. Now, to just level with you, I heard Irena ask a question, or assume, basically, that we all know Prithvi. Who actually does? 2, 3, 4. Okay, who has never worked with any big data, EO data, or foundation models? Who has never accessed satellite data? Okay, well, 5, 6 of you that might actually learn something today. The rest, stick with me. I hope there's something in it for you anyway. There's a bit of history, there's a bit of outlook, but it's mostly about what's available and how can we use AI to, let's say, machine learning to make it more usable. There we go. Part of this we've done. I know a little bit more about you now, a bit more about me, coming from a country not that far from here, tulips and windmills. And it's only when I moved to Switzerland that I learned about the existence and the need for satellite data, because in the Netherlands, on a clear weather day, you basically see the whole country. You don't need to look from the sky. Then moving to Zurich, realizing not only do you pay different taxes, 5 kilometers north, south, west, east? Not only do you speak a different language, but there's actually the chance that there is different snow cover. The vegetation is in another state. You have different elevations, so it makes sense to look from above. That's when I started to become interested in satellite data, and it's this intrinsic law of fascination for looking at Earth from above that I want to share with you today. Who has heard of the National Point of Contact? 1, 2, 3, 4. Very good, thank you. We are, in fact, existing since 1981, initiated by ESA, because every country that was a founding member of ESA needed to have a body that could consult its inhabitants on how to use satellite data. This still exists in Switzerland. We are a group in Bern, basically focusing on commercial data and on the operational side. And then we are a team of 3 in Zurich, based at the University of Zurich, where we are scientific consultants. We help you with open source data and how to apply that in your use case, how to interpret data as well. And this is a free service for all of you. It doesn't matter if you're in an entity, in a profitable organization, or if you're a researcher. Whenever you have questions, feel free to reach out. If we don't know the answer, which could very well be, we at least know many, many players, and we're there to link you to those. All right, the business case. It's a big market, Earth observation. Here we see a figure, there's many, many estimates, but here we see a figure, recent figure by Deloitte and WEF, estimating what the annual global economic value for the EO data is per industry. So this is annual in 2030, meaning up to there, we're talking not billions, because these are billions, we're talking trillions. In light blue, agriculture, huge potential, because agriculture is such an insane market that only if you get a little bit of an improvement using EO data, you already gain that much. Mining, oil and gas, traditionally big sectors, government, public, emergency services. The big sectors, in fact, for all the commercial data, probably the only viable contracts that they get are from defense organizations, because really the commercial business model to us, like private people, isn't really been successful so far. We see some sectors that we would expect. Then there's others that we expect a little bit less. Health is coming up. Construction sites, of course, coming up with better and better resolutions, different sensors. Tourism and the service industry, you're probably going to use EO data without even knowing you're actually using it. All right, you now convinced this is a big market, I want to go into that direction. Where do I start? A very short recap of what is satellite data and why is it different than normal photography. We're talking in different resolutions. So what do you actually want to observe? Irina showed already many use cases just with SAR data. There's many more. You have the optical data, you have LiDAR. There is a booming trend of the hyperspectral data and all that we can do with little snippets of the spectrum instead of just the big blocks that we've used so far. What can we learn by looking at the Earth not once, twice per year, but actually every day? What processes can we discover in more detail? Radiometric resolution plays a part. Well, these are the obvious, but for every project that you want to start, if you're completely new in this field, ask yourself these questions. What do I really need to see? It's not always the case that you need the highest resolution. Maybe you want it, but it's not useful. This also links, of course, to the amount of data that we use, demand, and need to store somehow. The use case is clear. If we look at that from a historical point of view, we see that in the 1960s it started with intelligence agencies trying to observe each other, talking about the two big obvious players. I want to see what Russia is doing, the Soviet Union. I want to see what the US is doing. In dark blue, we see the actual payloads. This color dark blue, so it's the bottom line. And we see a few interesting jumps in the slightly brighter blue here as well. Just to mention to you, so it explains the figure. There was a Chinese anti-satellite test in 2007, sending a rocket to a satellite, resulting in a lot of debris. Then there was the Iridium Cosmos collision in 2009, also causing a lot of debris. And in case, sorry, I forgot to mention, but these are objects in space. Didn't mention that. These are the amount of objects in space bigger than a golf ball. Yeah? So we see a few jumps, and then a sudden increase in the actual dark blue sector, the actual payload. And this is explained by the rise of new space. Not the traditional space agencies that we know as NASA, ESA, JAXA, but commercial companies like Starlink, the whole Musk and Bezos boom. And we can see that we now have around 13,000 actual payloads. Of these 13,000, maybe 10% does Earth observation in whatever sense. Most of the others is telecommunication, and just Elon Musk owns about 7,000 of these 13,000 active payloads. That's where we are. Is it going to stop there soon? No. Predictions are by 2033 we will have 5,400 Earth observation satellites. So that's a multiple of what we currently have. I already mentioned commercial data. there is still the free data, and this will hopefully remain, because the commercial data, as you see, only started in 2015, 16, 17 with Planet Labs. But for long time series, which has been a topic in many of the presentations we could see today, we actually need to go back further in time. And Sentinel goes down just a little bit further, 2015 at most. But if you want to go even further, you need to rely on Landsat data, the American product, NASA product. And that goes down to the 80s, in some sections even 70s. Why is that interesting? Well, there's nothing else, with Sentinel being the mostly used nowadays, but it only goes back that far. And within the Sentinel, I just want to highlight the amount of data that we are downlinking. We have Sentinel 1, 2, 3, 4, 5, 6, all doing different stuff. This is only a very small amount of these 1,300 Earth observation satellites that we mentioned before. And if you talk about Sentinel-2, there's 3 of them currently active. Each of them sends 1.6 terabytes of data to Earth per day. That's about 1 million iPhone pictures of your brand new iPhone 17 per day. What are we doing with this data? And what could AI do to help us with this problem that's obviously occurring, not only in the data storage, but even the ground stations having difficulties of constantly downlinking all the data, because the commercial satellites do use the same ground stations as the free and open satellite data. I come back to the data part later. If you want to access this, there's a massive QR code. A very intuitive browser. I see at least 1, 2 people taking their iPhones. Nice. And you see the last image over Zurich, cloudy as it is most of the time. Have a look if you've never been there. You can go through the Sentinels. There's some other satellites you can choose from. And the delay in availability is, yeah, it should be a few hours, but it's mostly the next day that you will find the image of the previous day. And you see an interesting filter here. Cloud cover, obviously depends on which region in the world you are, but if you filter out the images with clouds, then in some regions there's really not many images left. The question is, do we then need to downlink all these images? Do we really need them? Talking about the commercial satellite overview, and I will also show you where you can access these in a generalized platform. Planet Labs, I mentioned, delivering an image every day over the whole planet of 3-meter resolution. Maxar and Airbus are the other 2 big players, especially in the optical field. Black Sky, and then there is a few radar sensors as well. ISI is a big player with sovereign nations actually ordering constellations. This is a new trend where countries ordering complete satellites from commercial companies. And what we will see is that the LiDAR sensor is going to be implemented more and more. It's a difficult challenge. We've heard about JEDI today. That's actually on the International Space Station. And the difficulty there is also a little bit difficulty to interpret this data correctly, is that the International Space Station gets corrected a lot in its orbit. So, and that's not just meters, that's kilometers of difference in the distance between the Earth and the actual space station. So it's not the optimal setting. And believe it or not, only 5% of the Earth has now been covered by LiDAR data. This is mostly done with aerial sensors, so on airplanes. So there's a lot to gain still, and this will just continue, and the data will get bigger and bigger, hyperspectral data, talking about gigabytes per image. This is one of those platforms where you can filter through the commercial data sets, see what's in the archive. If it's not in the archive, or if you want to order something in the future, you have to often task these satellites. And they can tell you, okay, we're going to try to get this image in the next couple of days. Taking you back to how it all started. I mentioned the 60s. This is how it looked like on the left side. A Soviet airfield, the very first image that was retrieved from space, the very first Earth observation image. On the right, a modern Sentinel image of the same spot. Not too different. Spatial resolution is actually not too bad. We can see the airstrip in both. It's just that the radiometric resolution was a bit less. The angle was not perfectly nadir. But now we have this. That's great, right? Well, if we shift that, if we zoom in, then now we have on the left, we have the Sentinel open data. And on the right, we have what commercial satellites can do. It's the very same location in Singapore. And if we ever get asked, will we get to a point where we can read the number plates on cars? We're getting closer, because you can tilt the cameras on these satellites, and we can actually look what's written on the buildings already. Not in this very projection, but you could read Fullerton Hotel there. So we're getting there. Did anybody of you think how that data from the 60s came back to Earth? Any idea? It's kind of given away here, but it still probably blows your mind to hear. There was several films with kilometers of negative on there, in like 2, 3, 4 different capsules on the satellite, on these Corona satellites. And these were then ejected back into the atmosphere. They would open a parachute, and specially equipped Air Force airplanes would localize them and snap them from the air. And that's how these kilometers of film came back to Earth back in the days. Nowadays, of course, this is a different story. Downlink into big, great ground stations, so a lot of the romance has definitely disappeared here. But quantities have increased. Brings me finally to this question, what can AI do here? And what we see lately is that onboard processing. What I'm talking about can be a multifold of processes, and we're going to go over a few. Some of them are in developmental stage. Some of them are actually now in operational state, in operational missions. And both in private and in national agency settings. For example, the wildfire solution of a German company called Aurora Tech. Instead of sending a raw image over a potential wildfire, they've already created a dashboard that makes the satellite kind of an Internet of Things sensors, an IoT sensor. So we as the authority that has to go there and rush to the spot and make sure that you control the fire, you don't need to see that raw data. It's enough if the system tells you, hey, there is a fire, it's here and here, and this is the intensity. And this can nowadays be done on board, on the satellite. So we don't need a lot of data being downlinked. Plus what they do, they don't wait till the satellite passes over a ground station again. There's a link between different satellites, and they have a whole constellation. So there's always a satellite that's directly above the receiving ground station. And through this connection of satellites, it's a matter of seconds, minutes at most, instead of hours that you get your ping saying that something is up. You can think of concepts of having a forward-looking camera on board of the satellite that already tells the other sensors on board, look, it's so cloudy there, don't even bother taking pictures. Or at least it's telling this to the optical sensor, whereas you have the radar sensor on board as well, which is then triggered to say, hey, focus on the other direction. It's so cloudy there, but we have flooding. We report of floodings, and floodings obviously often come with cloudy atmosphere. So you tell the radar sensor to prioritize this very region, focus there, do some onboard processing, check the quality of the images, and prioritize images actually that need to be downlinked for disaster management. Again, we're not talking about hours anymore, of days even, of processing down here. We're talking about seconds, minutes before the signal reaches us. So this is a very interesting development. And why I showed you the history of the Corona satellites with the film that we need to develop. I like the idea that while we laugh now and we look amazed that, wow, they did that with parachutes and they snapped them from the air. I think that maybe in a few years, few decades at most, we will look at the current state of just like mass downlinking and building more and more storage centers, that this was absolutely ridiculous compared to what's coming. You can throw away so much data that will never be looked at. But then there's scientists, and they might say, yeah, we don't know what to do yet with cloudy images, but in 10 years, we might have new techniques, new indices, new models that are actually very interested in having this archive of cloudy pictures as well. So I don't know where it's exactly going to go. We're probably going to get a mix. In use cases like the wildfire emergency, it's really enough to have the ping. But if you're talking about for the Sentinel missions, maybe we just keep doing that. Also, there's a bit of a downside to operating this kind of compute in space. It's a harsh environment. The radiation damages the instruments. There is research being done in how good can we trust an algorithm on board of such a satellite, because how do we know if maybe the radiation flips a bit? It only needs that much. We won't know, but the whole output of the algorithm would be different. Radiation, one point, then the heat is another point. You think it's cold up there, but there's no convection of heat. There's no conduction. So everything you put on board of a satellite heats up, and it's very hard to get rid of this heat. That's another point. Then if you want to go back to the radiation, if you want to shield your sensors from this radiation, you actually have to work with very heavy materials, which makes your little modern CubeSat a whole different story. So that's why this has not been done all over yet, but we're experimenting, and it will definitely be a whole different angle to AI and Earth observation that might be interesting to keep in back of your mind. I'm focusing a bit more on this one because next up would be usability and foundation models, but since the experts have already spoken, I won't talk too much about that. How do we actually go from collecting kilometers of film to actual insights? For example, like in this, I find it a fascinating image where Sentinel-1 data and AI was used to track shipping vessels and then link that to all the ships that actually have their transponders on, which is the blue ones. And then there is the yellow ones that are not publicly tracked. Call them illegal or not necessarily illegal, but these kind of insights, we definitely need AI to help us. We've covered this. What we can do on board, of course, is done on Earth nowadays. Detect the patterns, the changes, image pre-processing, talking about this cloud removal, data fusion, image reconstruction. Then the most common applications of machine learning in remote sensing nowadays being the classification, like do we see this or not? Very binary in a sense. Is there a flood or not? Is there a wildfire or not? Left, right. Then there's the segmentation. All these use cases, I go over them quickly because they've been mentioned. There's the object detection, maybe in more high-resolution imagery. You can object even whales or dolphins. And the regression, actually a product derived from JEDI again, linking to the biomass. These are all tasks that nowadays, so I've shifted from onboard processing to on-the-ground processing, are the most prevalent ones. Then as a user, do you have to go over this every time you start a new project? Do you really have to go over the pre-processing steps? No, less and less, because there's a big community that has done that for you or is doing that for you, and you can rely on this. The foundation models have been mentioned, but even the Swiss have since, I think only since a year, now this Swiss EO data set. You can find it in the Stack catalog. And it's Sentinel data, but they have given it the Swiss touch, which means they've made it even more precise. They've removed the clouds for you. There's now a sub-pixel accuracy of where it is located. And since different Sentinel orbits come with different projections, the Swiss have uniformed this, and all the images in this database are now the same projection. So if you're interested in working with purely Swiss data sets, it would be your go-to source. Another one would be the Major Tom core. I see Dr. Mikolai here. I'm not sure he's going to talk about Major Tom. Oh, very good. I'll leave it up to you then. And the Major Tom frame, data frame, basically. Yeah. If we go one step further, of course, it's super exciting. Alpha Earth Foundations, Tessera has been mentioned, Prithvi has been mentioned. So probably in the last 5 minutes, open your LinkedIn, and there's a new model being announced. It goes that quick. One of my tasks is to keep up to date. I can't. I simply can't. But it's very exciting stuff. What I want to highlight is the generative foundational models. We've heard in an earlier talk that what do you do with missing data, or like if you have missing modalities, well, you leave them out. You don't have to anymore, because they can just be generated from the other modalities that you have. You throw in a Sentinel-1 image, you ask to poop out, sorry for my words, Sentinel-2 image, and it's getting closer and closer to a very reliable image. So if you have gaps in your data set, you can fall back on this kind of generative multimodal models. Even gets elevation models out of your radar image. Like, stuff is very, very fascinating. Regarding usability, I want to highlight the vision language models, because in the end, that's the easiest interaction we can have with an image. We talk in natural language, and we get out what we want. You ask the data set, show me the fire, show me the glaciers, show me whatever you want to see. One Zurich spin-off, Ask Earth. Have a look at them. What they do, they incorporate many different data sets as well that really let you talk with the data and get insights out of that in the language we all know so well. Finishing off here, just one more thing. I'm a geologist, glaciologist by training, so there's no way that I can finish a presentation without showing. Yeah, but there's something weird, right? So the answer is Blatten, the Blatten landslide. I just asked, thinking in this presentation, I just asked a couple of GPTs to predict how it will look in 20 years. And I gave them the input image, the actual image, taken by a commercial satellite on the 30th of May. And then, how will it look in 20 years? Well, some interesting aspects. The snow cover is completely gone, realistic. The trees are a bit too high up. The lake is drained, beautiful. The actual village of Blatten is not restored there. The houses here still exist. But there was no reasoning behind it, so I asked another model. Claude told me very, very smart stuff. There will be a 65 to 75% vegetation recovery. There will be a reduced snow cover, stabilized water channels, some rebuilt infrastructure, and I made it look like a very realistic satellite image. Are you ready for the result? There you go. This was Claude. And then reading a little bit about this deepfake geography, I found this line: the untrained eye may have difficulty detecting the differences between real and the fake. All right. With that, I want to thank you for your attention. Don't hold back. Ask us your questions. As said, if I don't know the answer, we link you to the people that do know. And do not always believe the data that comes out of your machine learning models. Okay. Thank you very much.
Thank you very much for your presentation. Do we have one short question? Yes, please.
Thank you for your talk. Very good to also see the practical application. I was wondering, for Switzerland, you presented some products that are also commercial at high resolution. So I was wondering, which one would you recommend maybe for research that we could buy, or yeah, because we need usually time series and we need accurate data, and then that means that SwissTopo is sometimes not providing such time series data. Mm-hmm. So which one of those products that you presented here you recommend to use at, let's see, under 1 meter resolution, spatial resolution?
Okay. Then SwissTopo cannot help you, because then also the aerial image that you find on SwissTopo is takes them 3 years to cover Switzerland. So the product I showed you is the Sentinel, right? Just with the Swiss touch, which is not enough in use case. Then we go into the commercial satellite data, and for that I would be happy to talk to you afterwards, or even link you up with the team in Bern that can give you the prices per square kilometer, blah, blah. Because they are the official resellers of the commercial data. Yeah, but ask yourself if you really need this.
Thank you.
Thank you
very much, Jochem.